would love to introduce our next speaker, Noorain, aka YourTechBud. He's a founder, a speaker, an AI enthusiast, building agentic platforms and guiding engineers from curiosity to mastery. Please welcome Noor.
Thanks for having me, guys. It's always so good to be back in Van.js. I think I'm here after a year, it seems like. Oh my God, it's been long. All right, so my name is Noorain. You can call me a tech bot. You know what, let's just skip about me. I've been in AI for the past 2 years, I guess now. Before that, I was in cloud computing, set up the Kubernetes practice at my current company, and now I'm consulting the likes of Levi, Delta Airlines in their AI practice. So there are 3 important points which I want to share. I'm going to talk about things which are based out of my personal experience. So it's now validated like throughout the industry. I don't have any crazy report to share with you, all right? But it's working with some bigger Fortune 500, so might be relevant. I've seen companies from the early ages to somewhat productionizing, but none of the customers we've worked with are at scale yet. So again, keep that in mind. That was point number 1, all right? So based on personal anecdotes. Second, I'm going to be talking about a tool. So I don't want you to focus on the tool though. We want to talk about the philosophy behind the tool or the approach it's getting to the table. That's what's important. In fact, the tool I'm going to show sucks. It's really bad. Never use it. We technically have deployed the Python version of this for one of our customers, but the JavaScript version is just really, really, really bad. All right? So don't use the tool. But again, we're going to focus more on the mindset, a different way, maybe for most of us, to think about building AI systems, which might answer some of the questions which were asked as well, right? Sounds good? And third, the most important point, how on earth am I supposed to concentrate with everybody? Like some of you have some amazing costumes. I don't know how it's going to work out. I'm going to try to be focused, but it's probably not going to work out, all right? Sweet. Okay. There's just one last thing. So this is going to be a little different, and 20 minutes is too tight to pack all of this in, so we are blitzing through it. So we just have to have one little equation between us. When I raise my hand and I ask a question, I want to hear a yes. Simple. Yes. Yeah. Are you guys with me? Yes. Once more. Are you guys with me? Yes. All right, cool. The power in that yes will help me understand whether I should move on or not. Because let's see how many of y'all can keep up. Oops. So, all right. So we're going to talk about problems, and let's just get into it, okay? The tool you're seeing on screen right now is BAML. There's nothing against BAML. We'll start. Okay, the way I've structured this is that we're going to start with some problems which I've seen. Oversimplified, of course, because we cannot get into like the actual use case. It's just too much. Okay? Simplified version of the same problems. Sounds good? Then we're going to talk about a new mindset, and then we'll see some code on how one Stanford-based team has implemented it. Sounds good? Yeah? Simple structure. Okay, so what we're going to be building is okay, I need to be inside the camera frame, right? I move a lot. I think I'm going to make your life miserable. Okay, sorry about that. Okay, what we're going to be building now is a simple task management app. We give it questions. We just give it statements like, hey, I did something, and it's going to update my to-do list, right? Now, that also could be a complex app, so we're just going to look at one part of it, which is the first step, identifying the user's intent, right? The first step to any task management app would be intent identification. For example, I bought my groceries. We need to mark a task as done. I don't need to buy a badminton racket anymore because I suck. Delete the task. I need to get a life. Wishful thinking, intent classifier. That's how it's going to work. Sounds good? Okay, so here's my prompt. That's how we usually start. We write a simple prompt. Oopsie. You did not see this part. We did not see this part. Sure. Good enough? Alrighty. One more? Oh my goodness, it's going to be very hard for me. I might have to zoom out, but okay, we will try to work with it. Simple prompt. Okay, I'm not going into prompt engineering for now, but this could be pages long, right? But imagine it's a page long, okay? And I've made a very sophisticated prompt here. We're going to identify the user's intended action based on the query provided. Actually, forget the syntax. We don't really care about the syntax. But this is what the prompt would look like at the end of the day. We have a system message, identify the user's intended action based on the provided query, answer in a JSON format, where the action could be one of our intents. And then my query is, I bought my groceries. I did not. But okay, you know what? I bought my groceries. Sounds good? I run this task. I'll get back a response. And it says, mark task as done. Perfect. Because I bought my groceries, most likely I want to mark that task as done. Classifier works. Yippee. But life doesn't work that way. Because what happens is, a cheaper model comes out. And with most of our customers, we've seen that they start with bigger models, but eventually they have to trickle down to smaller ones. Because they start with a big budget, but the budget just disappears. I don't know how, it's magic. And we have a magician between our midst right now. But I don't know what you're doing, but the budget just keeps vanishing. So what happens is, we have to change the model. We have to go for a cheaper, faster model. So we're going to go from Gemma 3, 12 billion, which is already a small model, to 5.4, 14 billion, which is a much faster model and kind of cheaper as well. It's by Microsoft. Now, if I run the same prompt again, what's going to happen? Actually, we don't know. And it's taking a lot of time. It's not supposed to take time. Oh my God, is my internet bad? Can we skip it? Come on, come on.
Sorry, you went from 12 billion to 14 billion.
So just because you're adding weights doesn't mean it's better. Doesn't mean it's better.
Doesn't mean it's
No.
better, but it means it's bigger.
Doesn't mean it's... So Gemma 3, because it's kind of a more slower model, like the architecture is a little bit more complex, so the inference speed for Gemma is much slower. 5.4 has a much faster inference speed, even though it's a slightly bigger model, which means it spends less time on the GPU, which means that your cost is going to be less because the throughput is much higher. It doesn't matter. It doesn't matter. The model is inconsequential. It's inconsequential. Okay. It's no. This is not a dense. This is a dense model. The models doesn't matter, guys. The point is the model will change eventually. Eventually, something like Gemma 2.0 will come out in the era of Llama, and they'll go like, oh, you know what? The cost just got slashed down to half. You will want to change your model eventually for the pricing. But the problem is every model comes with its own prompting technique. Its prompting guide. I don't know how many of y'all went through the Anthropic ones or the OpenAI 4.1. Amazing, very different though. So even the same task which works for one model which was smaller, sure, maybe smaller is worse, let's go with that. The bigger model fails at it. This happens. Right? So you know what? We'll bite the bullet. We'll be like, okay, let's not change the model because we really don't have time. So, okay, now we're back to working. But another thing hits us. It eventually reaches end users, and end users are monkeys. Monkeys go bananas, right? So they come up with a new use case. And I mean, who better to learn from end users, right? So they come up with a new use case, and instead of saying, I bought my groceries, they're like, I don't need groceries. Valid, right? I don't need groceries. Why? No space. Maybe I don't know how to. It doesn't matter. I just don't need groceries. Don't ask me questions. So now if I go back with the same prompt and just slightly modify my query saying I don't need groceries, it shouldn't work. Let's try it again. It did not work. It still works. Why is it working? You're not supposed to work, my friend. It works every single time. That is insane. It did not work. Okay, reliability is a little low. But it kind of screwed up. And that happens. The point I'm trying to illustrate is, eventually your use cases evolve because end users will start pushing the boundaries of your system. It's going to happen, right? And your prompts are not designed to keep up with them. And this is going to happen. It's fine. Your prompt cannot be perfect, right? So what do? We go back to prompting, and then we add some instructions. Like in this case, again, poor prompt engineering skills. I suck at it. Instruction is use delete task action whenever you think the user doesn't need or care about a task anymore. So now if I run the delete task, that works. But if I go back and run the previous task, That doesn't work. So modifying the instruction inevitably broke one of the 100 test cases I had. Are you guys with me? Make sense? Feels relatable? A little bit? Yeah? This is the nightmare of maintenance. Developing AI apps is easy. But the moment you have to go and modify things, that's when you're almost like, you know what, rewrite the entire freaking prompt at this point. And you have no idea how many different prompt techniques I've used. How many of my unborn kids I've sacrificed to ChatGPT. It's just so much. Please make it work, otherwise my kids will die. And they've died because the ChatGPT prompt wasn't good enough. It just works that way, okay? So there are two problems which we're talking about. Of course, there are more. I'm not saying this is an exhaustive list. But the two problems I'm here to talk about is your models will change, which it should, because models are going to get cheaper. Two, your use cases will evolve, which it should, because hopefully you're onboarding new customers. And hopefully people are using it. Your prompts will have to keep up with you. That's the problem. So let's look at the philosophy now, okay? We're going to get into theory, and we'll see code. Don't worry, we'll see code, even though the code is absolutely disgusting. We're going to see it. So this is me, as cute as a button. So what we do in our normal prompting, and it doesn't matter what tool you're using. I'm using BAML, but you might be using what? LangGraph, LangChain. Please, no LangChain, no LangChain. Pydantic, it doesn't matter what tool you're using. You're writing instructions, system prompts, some form of prompting, right? So what we end up doing, I call it prompt fiddling, because you're kind of doing unspeakable things with the model, which you shouldn't say out loud, but you're kind of messing around with it in an inappropriate way, right? And then every time you make a change, you have to run your evals and you hope and pray, oh, please, it works, right? And then if it doesn't work, you go back to prompt fiddling till all of your test cases or the quota or the threshold of your test cases pass. And then eventually it works and you're surprised because why the hell is it working? And of course, the empire strikes again. There are new changes. You come back to prompt fiddling and now you're in the inevitable loop of pain, right? That's AI engineering. And unfortunately, I was born an engineer. I was actually born an engineer. It's a long story. We'll get to that later. But that's not engineering. That is not a scientific way to do anything, right? I mean, I can't work that way. So let's introduce a new way, okay? So the problem with the existing way is that writing prompts is like writing assembly code. How many of us writes assembly code? Yeah? Please go out the room. We don't care about you. I knew there would be at least one or two over here. Okay, so like writing assembly code. Assembly code is code written precisely for an instruction, for a processor architecture, which like you write instructions for Intel, it would just work on Intel, but not only just on Intel, it won't even work on the next generation of Intel perhaps, or the older generation, because the instruction set can evolve and maybe it's not optimized anymore. The point is, you're writing it for one particular use case. Every time you want to change, you cry. Do you cry? Say yes. Yes, that's it. I did not bully him into it. So the point is you're writing assembly code, you don't want to write assembly code. What do we normally write? Please say TypeScript, it's a TypeScript frigging event. And TypeScript is a higher level language, so you're writing things which has more semantic meaning to it, and you let a compiler or an interpreter convert it into the assembly instructions for you, right? But we don't have that interface for AI. We don't have that. People say English is great, English sucks. It's so subjective. Every model interprets instructions in different ways. It just doesn't work, right? It doesn't scale. So English is really bad. So what's a new way of doing it? How do we normally make APIs? The first thing we do for APIs is we figure out a contract, right? A schema, like a Swagger spec, right? Open API spec. Some kind of a spec. This is the input, this is the output, right? That's what we call a contract. A contract. We start with the contract. How is it implemented? Do I care? Probably not. What I care about is this going to power my user interface? That's what I care about. So we start with the contract. We don't care about the implementation. Then we go ahead and fill up the implementation. We select a strategy to implement it. What does it translate to in the AI world? Is it going to be one LLM call? Is it going to be an agent? Is it going to be a series of LLM calls in a workflow? How are you going to implement that contract? It can change. It starts with a simple prompt because, hey, simple use cases in the beginning. Becomes more complex, you need a workflow now. So the contract can remain the same, but your implementation can change, okay? But still, nowhere have we written prompts. We're not writing prompts. So what do we do instead? We collect data. And data is really easy. Like if you're using Copilot or I don't know, Cursor or whatever, it can generate a lot of synthetic data for you. Again, good to get started with. I'm not going to say it's production ready. Getting good data is a continuous process. It's never completed. You start with something and you write evals. Hopefully everybody's already writing evals. Please tell me you're writing evals. You know what? I'm just going to take it as a yes, or I'm going to get nightmares. I won't be able to sleep. So we're collecting data and we're writing evals. Then we run the compiler, which I misspelled, of course. Doesn't matter. The compiler will take that examples, evals, run it across your strategy, and it will generate a prompt for us. So now our system has become a machine learning system which will figure out the best prompt for us. Let that sink in. We just built a machine learning system. You have training data. You have a way to evaluate whether your system is giving feedback to it. And now you have a machine learning system which can technically figure out the best prompt. Don't worry, we'll see the code. But you see where I'm getting at. Instead of starting with the prompts, we're starting with a way on how we're going to test it. And most importantly, what we're going to test. What's the contract? And once we have a good evaluation, instead of the best prompt, once we have the best test suite, we can be assured that if this test suite passes, whatever prompt it was, it's going to be good enough. Make sense? Are you guys with me? Okay, we're still here. Okay, now the arrows are missing because you can see this was last minute. So I just assume the arrows are there. So it works. Now what happens if there's some new data? What happens if there's a different model? You just run the optimizer again with the new model. No changes required, right? Because the optimizer will create a prompt anyways, hopefully. Assuming the new model is at par with the previous one. The parameters could be less, but as long as you get the same result, it's fine, right? So new model, just run the optimizer again. New use cases, update your data set. Just update your data set. Maybe modify your evaluator. We'll talk about the evaluator again. And run the optimizer again. So the new prompt will hopefully have instructions to accommodate that new use case as well. Let's say no matter what you're doing, you're just not getting the good prompt. Maybe your model is screwed up. It's time to change the implementation of it. Maybe one prompt is not enough. You need to break it down into two. So you're changing the implementation of it now, but not the contract. The contract remains the same. And because the contract is the same, your code base remains the same. Right? If your API remains the same, even if you change the database from underneath, your front end, does it change? It doesn't. That's the beauty of APIs, right? Exactly. That's how AI should be done. Okay. You guys ready to see some code? A little bit? Does it make sense? Okay, let's look at some code. So the tool, how much time do I have?
13 seconds.
We're now looking at some code. You know what? I'm just going to show you the final piece. So this is how you would write it. Oh, wait, what? 0, 1, 0, 1. This is how you write it. Essentially, you just initialize an LLM like you normally do. I'm using OpenRouter. You have a signature. So signature is your input-output contract. So it's a task, it's an intent classifier, right? So my input is a query. My output is an action, right? That's it. And that's how you use it. So this is how your program looks. The next step was evaluations and optimizers. I'm sorry, I'm just rushing you into this. But what we first do is we create an evaluation function. So you're just saying that prediction is the output from your module, like what the LLM or the system you built thought is the right answer. Example is your training, your sample example. Now, what you do inside the function is up to you. Because mine is a simple intent classifier, I can just do an equals to match. But what if you're doing RAG? What if it's subjective? You could actually make an LLM call here. You could make multiple LLM calls. Is there profanity? Did this cover all the 3 important points which the answer should have had? You can do whatever you want in your metric function. Go bananas with it. In fact, the metric function is going to be 100 times bigger than your module. That's how it works. It does get complex really quick. Once you have the metric, you need the examples, just some training data. Example doesn't need to be input and output. It just needs to definitely have the input, and you need some way to figure out whether the output is right or wrong, which could be deterministic, like just a simple match or LLM calls. Okay? Simple so far, right? It's just basic ML stuff. Like we learned this in, I don't know, engineering, I guess. And then you just set up an optimizer. We won't get into it. I'm so sorry. We won't get into it. And the optimizer will produce an output like this, which I lost. That is great. It produces an output like this. Basically, this is a few shot example optimizer. So what it does is it creates some sample input-output pairs, which it can give the model in its context window, so that the model kind of has an idea on how to solve novel use cases. It's called few shot prompting. It figures out the few shots for you, and the accuracy went from 75% for a normal model to 91% for the same model using this approach. You have to just take my word on it because she's already giving me the eye. I think she's gonna kill me. I'm scared. I guess I'm just gonna end it here. Yeah, I'll take, but just I'll show them a link. So I know a lot of you might be wanting to get into AI. So if you are, I'm going to be creating a lot of content, workshops and stuff for practical AI, like stuff you actually do and you can use and gives you benefits. You might want to subscribe to my Luma page if you're interested. It's going to be online and offline, might be helpful. And those who are actually learning AI to get into it, I would love to have a word with you. I'm not promising solutions here, but I just want to understand how you're going about it. Maybe I can put you in touch with somebody or help you out somewhere. So if you're interested, learning AI by yourself, I have some questions for you, maybe some solutions as well. All right? Thank you so much. My name was Noorain, YourTechBud. You can just check me out on LinkedIn. Sorry, I forgot my name. And now, yes, you can please clap for me.